There are places in the universe so distant that even light from our own sun no longer feels familiar. Beyond the planets, beyond the icy frontier of the Kuiper Belt, and far outside the protective bubble created by the solar wind, an aging spacecraft continues a journey no one expected it to survive. Every signal it sends must cross nearly a full day of empty space before reaching Earth, carrying whispers from a region humanity has never explored firsthand. The latest transmission from Voyager 1 has once again reminded scientists how little we truly know about the vast ocean between the stars. This tiny spacecraft, launched nearly half a century ago with technology that now seems primitive, is still performing one of the greatest scientific missions in history. It has outlived generations of computers, survived countless technical failures, and traveled farther than any human-made object has ever gone. Originally, Voyager 1 was never meant to become an interstellar explorer. Engineers designed it for a relatively straightforward assignment: visit Jupiter and Saturn, gather measurements, photograph their worlds, and then slowly fade into silence. It was expected to complete its work in only a few years before becoming another forgotten piece of space history. Instead, something extraordinary happened. Each encounter with the giant planets gave the spacecraft a tremendous gravitational boost. Jupiter accelerated it. Saturn redirected it. Together, those worlds flung Voyager 1 toward a destination nobody had imagined during its construction. Rather than ending its mission among the planets, it began an entirely new chapter beyond them. Decade after decade, the spacecraft continued moving outward. It crossed the orbits of every major planet, left behind the familiar architecture of our solar system, and approached a boundary that had existed only in scientific theories. In 2012, Voyager 1 accomplished what no spacecraft had ever done before. It crossed the heliopause, the invisible frontier where the influence of the Sun finally gives way to the immense environment of interstellar space. That crossing was far more important than simply breaking a distance record. For the first time in human history, a machine built on Earth entered the medium that fills the galaxy itself. Voyager was no longer surrounded primarily by particles flowing from our Sun. Instead, it found itself immersed in ancient plasma shaped by events that occurred long before our solar system was born. Scientists expected this region to be quiet and relatively uneventful. Models suggested that the space between stars would be thin, cold, and nearly uniform, with only occasional disturbances passing through. But Voyager 1 quickly began revealing a very different reality. Instead of an empty, featureless void, it discovered a complex environment filled with changing densities, magnetic activity, and subtle structures stretching across enormous distances. The interstellar medium was not silent at all. It was dynamic, constantly evolving, and far more complicated than previous theories had predicted. Among its most fascinating discoveries was something that researchers are still trying to fully explain. Since 2017, Voyager's plasma wave instrument has detected a faint but persistent signal traveling through interstellar plasma. It is not a dramatic burst of energy, nor is it a temporary disturbance caused by solar activity. The signal remains remarkably steady, continuing year after year like a quiet vibration woven into the fabric of the galaxy. Scientists often describe it as a continuous hum. Of course, this is not sound in the way humans experience it. Space is far too empty for ordinary sound waves to travel. Instead, the spacecraft measures tiny oscillations in electrically charged plasma. When researchers convert those measurements into audio frequencies, the result resembles a soft, continuous tone, a subtle vibration echoing through the interstellar medium. The importance of this discovery goes far beyond its unusual appearance. That persistent signal allows researchers to study the density and structure of plasma between the stars with unprecedented precision. Before Voyager made these observations, Scientists often had to wait for powerful solar eruptions to send shockwaves through interstellar space before they could estimate its properties. Now, they can monitor the region continuously using the faint background oscillations Voyager continues to detect. Every new measurement reveals another piece of a puzzle that has remained hidden throughout human history. Even more intriguing is the fact that researchers still debate the exact source of this mysterious emission. Some believe it results from natural plasma waves interacting with the surrounding environment. Others argue that the movement of countless electrons creates subtle fluctuations capable of producing the persistent signal Voyager observes. Although the explanations differ, they all point toward the same conclusion. The space between the stars is far from empty. But the quiet hum was only one piece of a much larger mystery. Long before Voyager 1 fully entered interstellar space, it encountered a boundary that completely changed scientists' understanding of where our solar system ends. For decades, researchers imagined this frontier as a gradual transition, a place where the solar wind would slowly weaken while the influence of interstellar space steadily increased. The crossing was expected to be smooth, almost gentle. Reality turned out to be far more dramatic. As Voyager approached the heliopause, its instruments detected an environment far more energetic than anyone had predicted. Instead of a calm border, the spacecraft found an intense region where streams of charged particles collided, magnetic fields twisted together, and enormous amounts of energy were concentrated into a surprisingly narrow zone. Some researchers even described it as a wall of fire. The phrase sounds dramatic, but it does not refer to flames or combustion. There is no oxygen to burn in the vacuum of space. The name simply reflects the extraordinary temperatures created when high-speed particles are compressed and accelerated at the outer edge of the Sun's influence. The temperatures measured there reached tens of thousands of degrees, astonishing values for a place many people imagine as nothing more than cold, empty darkness. This discovery forced scientists to rethink the nature of the heliosphere itself. The heliosphere is an enormous bubble formed by the constant stream of particles flowing outward from the Sun. It stretches far beyond the planets, surrounding our entire solar system and acting as a protective shield against a significant portion of harmful cosmic radiation arriving from the rest of the galaxy. If that protective boundary is far more turbulent and dynamic than expected, then our understanding of how it shields Earth is also incomplete. Voyager revealed that this invisible frontier is constantly changing. It is shaped by magnetic pressure, moving plasma, and powerful interactions between material flowing outward from the Sun and particles drifting through interstellar space. Rather than serving as a simple border, it behaves more like a living system, continuously responding to forces on both sides. Another surprise emerged from the spacecraft's magnetic field measurements. Scientists had expected the Sun's magnetic field and the magnetic field of interstellar space to be clearly separated at the heliopause. Instead, Voyager found evidence that these magnetic structures interact in surprisingly complex ways. Field lines appear capable of reconnecting, releasing energy and reshaping the surrounding plasma through processes that older models could not fully explain. These observations carry enormous scientific importance. They help researchers understand how cosmic radiation enters our solar system, how energetic particles travel through space, and how our star interacts with the galaxy surrounding it. Every measurement improves models that describe not only our own solar neighborhood but also similar stellar systems scattered throughout the Milky Way. In other words, Voyager is teaching us far more than the story of one spacecraft. It is revealing how stars protect their planetary systems, how interstellar space behaves, and how the environments around distant suns may operate across the universe. Then, just as Voyager continued making historic discoveries, disaster nearly ended the mission. Late in 2023, engineers noticed something deeply unsettling. The spacecraft was still transmitting, and its radio signal remained strong enough to reach Earth. But the information inside those transmissions no longer made sense. Instead of understandable engineering data and valuable scientific measurements, Voyager began sending meaningless patterns that appeared completely corrupted. For a moment, it seemed as though humanity's most distant explorer had lost the ability to communicate. The challenge facing NASA engineers was unlike almost any repair attempted before. Voyager was more than 24 billion kilometers away. Every command required nearly 23 hours to reach the spacecraft, while every response demanded almost another full day to return. A single troubleshooting attempt could consume nearly 2 days, making even the smallest test an exercise in extraordinary patience. Adding to the difficulty was the spacecraft itself. Voyager's computers were designed in the early 1970s. By modern standards, they possess almost unimaginably small amounts of memory and processing power. After spending nearly 5 decades exposed to cosmic radiation, every electronic component has endured conditions few machines were ever built to survive. Months passed before engineers finally isolated the problem. The culprit was astonishingly small. A single damaged memory chip had corrupted part of the spacecraft's flight software, preventing it from correctly packaging and transmitting its data back to Earth. One tiny electronic component, smaller than a fingernail, had brought one of humanity's greatest scientific missions to the edge of silence. Replacing the hardware was impossible. Instead, engineers accomplished something remarkable. They carefully rewrote portions of Voyager's software, divided critical instructions into smaller sections, and relocated them into healthy areas of memory that were still functioning. Every change had to be calculated with extraordinary precision because one incorrect command might have permanently ended communication with the spacecraft.